afternoon and welcome back to Pad A at Launch Complex 1 on the Mahia Peninsula with a beautiful rainbow on your screen over there. It is 12:40 p.m. local time and we are on track to launch the Grain Goddess Provides. That is the latest mission for our longtime customer, the Institute of Q-shu Pioneers of Space, or iQPS. We've got just 22 minutes left in the countdown to liftoff from Rocket Lab Launch Complex 1 on the Mahia Peninsula in New Zealand, with launch scheduled for 1:01 p.m. local time. Thank you so much for joining us today. My name is Sam Peters and we're joining you from Rocket Lab's Mission Control Centre in Auckland, New Zealand.
And I'm Julian Spice. It's great to be back with you again for our 92nd launch of the year and the latest iQPS mission. It's a sunny and clear afternoon over the launch pad today. Our latest weather report shows only a 30% chance of violating our weather constraints today. And we're reporting no issues across the range, the rocket, or with the iQPS satellite on board.
Today's mission is called the Grain Goddess Provides. And if you've joined us for previous iQPS launches, you'll know there's a special tradition behind these names. Each satellite in their constellation is named after a Japanese deity, and today's satellite is no exception. On board Electron today is a single synthetic Aperture radar satellite called QPS-SAR-13, nicknamed MIKURA-I, which is said to be deployed to a 575-kilometer orbit. The SAR satellite is named after the Japanese goddess of food, abundance, and prosperity, a fitting name for a mission that's all about delivering valuable data to users around the world.
That's right. Each satellite carries a special kind of imaging capability called synthetic aperture radar, or SAR imaging, which measures the distance of radio waves being bounced back off terrain and buildings on Earth to map a picture of a particular location at any time, day or night. From disaster response to agriculture, urban planning, and beyond, these satellites are transforming industries by providing critical data when it's needed most. Let's hear more from the team over at iQPS about their mission.
Founded in Fukuoka with the mission of establishing a space industry in Kyushu, iQPS marks its 20th anniversary in 2025. Today, together with more than 25 partner companies, mainly based in northern Kyushu, we are developing the world-class small SAR satellite, QPS-SAR. SAR satellites use radio waves, enabling observation of the Earth's surface day or night in any weather. iQPS is steadily working toward a 36-satellite QPS-SAR constellation, aiming for near real-time Earth observation almost anywhere on the globe. Since launching our first satellite in December 2019, we have continued to expand our fleet and gained extensive expertise in operations. In March 2025, our new R&D hub, QSIP, was established. QSIP integrates manufacturing, testing, and shipping on one floor, enabling production of up to 10 satellites per year. This boosts efficiency and development speed, accelerating launches and service readiness. Partnering with government agencies, infrastructure operators, and others, we are already delivering results by combining satellite data with image analysis and AI. Our satellites are used for inspecting large infrastructure and monitoring wildfires, earthquakes, eruptions, and other disasters, helping detect crises early. As natural disasters and geopolitical risks increase worldwide, the need for our high-precision observation data grows more urgent every day. Faster, more accurate, covering more places than ever before. We will continue expanding our constellation, realizing a world where Earth is observed more frequently. Unlocking the potential of space and contributing to human progress. The challenge of iQPS continues.
We've previously launched 7 iQPS missions to establish their Earth imaging constellation, with 6 of those launches taking place across 2025, all from right here at Launch Complex 1. Today's mission is launch number 8 for the constellation, and we're excited to add another QPS-SAR to low Earth orbit in just a few minutes' time.
What's also is just yesterday that Rocket Lab announced its biggest deal ever with our bid bringing Iridium Communications into the Rocket Lab family.
Yep, it's a pretty bold move by us. The reason for the deal is to put us in a position to become the only company in the world that can build their own satellites, launch their own rockets, and operate their own constellation across the only truly global network that provides coverage over every ocean, mountain, and airway. To explain the whole thing in detail, here's our founder and CEO, Sir Peter Beck.
Last time I was wearing this blue jacket, I was announcing Neutron. So I guess that means there's something important to announce today. But man, this thing shrunk. Okay, we're going to go back to school for a little bit. I want to introduce you to the space application equation. So you've heard me talk a lot in the past about applications. It's where all the value in space truly lies. But in order to exploit that value to the fullest, you need a few other things. The first thing is unfettered access to space. So you need your own launch. And then of course you need your own ability to build spacecraft at scale. We've got that too. But there's some other really big barriers to building large, successful constellations in orbit. And the first one, spectrum. Spectrum is a finite, almost impossible to get, and of course, not all spectrum is created the same. The next thing is, it takes a long time to build and launch your infrastructure, a long time to design and build your satellites, launch them, and even longer time to get your first $1 of revenue. And then finally, it's a long time to a sustained cash flow model, a long time to build your business model, a long time to build your customer base, and it takes just that long extended time until you've got proper reoccurring cash flow. So those of you who know me will know that I'm way too impatient for that. So we found a bit of a shortcut. Rocket Lab is acquiring Iridium Communications. We believe this will be one of the most transformative deals in the space industry. It's the ultimate combination for growth. And if you think back to our little whiteboard session a moment ago, this is a deal where 1 + 1 = 3, not just 2. 1 being Rocket Lab, we have unfettered access to space and the ability to build spacecraft at scale. We also do missions for people that matter. And then when we think of Iridium, they have an already operational constellation, spectrum, not just any spectrum, extremely valuable spectrum, millions of customers, and they're a profitable business. So where the 3 comes in is the result of these 2 things is a fully integrated, self-launching space superpower. One that will unlock more growth from Iridium's existing network and build new constellations to unlock new services and market opportunities. This is officially our entrance into the space applications market, a thing we've been talking about for a long time now. But to be clear, this is not the finish line. Now, we won't just continue Iridium's network as is. We're going to build upon it to unlock new markets and pioneer new space-based services. Rocket Lab's future in space applications has just been unlocked and accelerated. And with that, I'm off to buy a new jacket. This thing's too small.
I think that blazer might be Pete's lucky jacket, honestly.
Yeah.
We might have to frame it up and hang it in the office for all the major Rocket Lab announcements he's worn it for. Anyway, there is so much more detail you can dig into about this deal across our website and social media channels. I highly recommend you go and take a look and get to better understand where Rocket Lab is headed and what our future is looking like. Now, before that countdown clock gets much closer to T0 for liftoff, our launch operations team has to complete their go, no-go poll run from Mission Control. Our launch director, Paula Tares Seralongia, will lead the operators at both mission control here in Auckland and range control at LC1 through the all-important go, no-go poll. This critical step ensures that every system is green across the board and ready for liftoff. The go, no-go poll kicks off at T-minus 12 minutes on the clock, so we're going to hand it over now to the launch director to take us through that poll.
And all stations held in mission core, proceeding with the go, no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Vicon.
Vicon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
FAN.
FAN is go.
LSO.
LSO is go.
And LDSUP.
LDSUP is go.
Go, no-go sequence complete. We are 11 minutes, 12 seconds and counting. We are go for terminal count auto sequence start at T-minus 10 minutes. From this time, the 3-core procedure is in effect. GCLD in mission core.
LDGC.
GC proceed with the launch pad with this sequence 60.
Copy sequence 60 in work.
All right, there it is. Our launch director has received confirmation of all systems green for the Grain Goddess provides. We are officially go for launch on today's mission with the T0 remaining set at 1301 UTC, local, 0101 UTC and 10:01 in the morning for our iQPS operators in Japan.
All right, T-minus 9 minutes and counting for our 92nd of the year for Electron and 4th this month. The rocket on the pad is Electron. You'll see it there on your screen, and its standard configuration as a 2-stage launch vehicle with a 3rd in-space maneuvering platform we call the kick stage. Electron is designed specifically to deliver small satellites to LEO on their very own ride. This gives our customers a dedicated, precise, and highly responsive ride to low Earth orbit from our launch sites here in New Zealand and on the eastern shore of Virginia.
Up, a suborbital version of Electron called HASTE is the rocket we fly from Launch Complex 2 for hypersonic test missions. And we've flown 9 of those so far of that version of the rocket that debuted just 3 years ago. Standing 18 meters or 59 feet tall, Electron is the world leader in its class for dedicated small satellite launch. Its black structure is made almost entirely from advanced carbon composite materials that keep Electron lightweight while maintaining the structural integrity needed to survive harsh aerodynamic forces of launch.
Yes, and what really sets Electron apart from traditional rockets is its revolutionary propulsion system. At the base of the first stage are 9 Rutherford engines with a single vacuum-optimized Rutherford powering the second stage. These engines are the world's first orbital-class rocket engine to be almost entirely 3D printed and powered by batteries. Its 3D printed design means a Rutherford engine's main structures can be made within 24 hours, which has been the secret sauce behind Electron's rapid scale since its debut in 2017.
All right, here's a breakdown of what to expect after those 9 Rutherford engines ignite for today's mission. From launch pad to delivering the iQPS to orbit takes just 9 minutes. Separation of QPS-SAR-13 follows about an hour or so after liftoff. The total engine burn time for Electron's first stage is about 2.5 minutes long before the second stage separates and the vacuum version Rutherford lights up to continue the mission to orbit.
Now, across those next 6.5 minutes, we'll have a couple of launch milestones to get through, like fairing jettison and battery hot swap, before we see another stage separation event to send iQPS's satellite on its way to orbit on Electron's kick stage. Now, at that point, it's a quiet 40-minute coast phase around Earth for iQPS and the kick stage, before the kick stage starts its propulsion system to round out the orbit and deploy QPS-SAR-13 to its 575-kilometer target altitude.
Okay, with a couple of minutes left in the countdown, we've got some time to tell you about one of the unsung hero products in our lineup of satellite components here at Rocket Lab. When we're not launching ourselves, we're finding other ways to help important missions get off the ground, and that includes one of the most exciting missions to head to space so far this year. NASA's Artemis II mission sent astronauts around the moon for the first time in 50 years, and every system on board the astronauts' Orion spacecraft depended on one constant: a reliable source of power.
And that power came from the spacecraft's 4 solar array wings attached to its service module, which was made with approximately 15,000 of Rocket Lab's advanced solar cells. It's an honor to contribute to such a groundbreaking mission, and we're excited to continue supporting NASA's Artemis program as it paves the way to greater lunar exploration and beyond. Here is more about the mission and the solar cells that powered it.
When NASA sends astronauts around the moon on Artemis II, they are venturing over 250,000 miles from home. In that deep space wilderness, every system on board the Orion spacecraft depends on one constant: a reliable source of power. That power comes from Orion's 4 solar array wings, the spacecraft's lifelines. These 7-meter arrays tilt and track the sun, but the real work happens in the solar cells that cover them: high-efficiency compound semiconductor solar cells. Integrated into these arrays are roughly 15,000 of Rocket Lab's advanced multi-junction solar cells. Unlike the panels used for power here on Earth, Rocket Lab's space-grade technology is engineered to capture more of the solar spectrum and to operate reliably in the harsh conditions of deep space. But in the vacuum of space, efficiency is only part of the equation. These solar cells are built to survive intense radiation, extreme temperature swings, and the mechanical stress of launch. At Rocket Lab, we know there is no margin for error. When these arrays deploy, they have to work, no exceptions. We are proud to partner with NASA and Lockheed Martin to enable the Artemis missions. By converting sunlight into 16 kilowatts of electricity, Rocket Lab provides the energy for Orion's propulsion, its thermal controls, and the air and water systems the astronauts depend on. As we help lay the groundwork for the Artemis era and the future of human exploration, Rocket Lab is honored to turn sunlight into survival.
The moment when Orion's solar arrays were deployed and our solar cells came alive for Artemis II was such a satisfying moment for our engineers and technicians who spent years designing, analyzing, testing, and building that technology. And with plans for a lunar base and more Artemis missions, we'll be putting more of that Rocket Lab technology to work to support human exploration deeper into space.
Today, though, conditions remain favorable and all systems are green for an on-time launch. Soon, Electron's autonomous flight computer will take control, managing the final 2 minutes of pre-launch checks and sequences independently. During this critical phase, the flight computer has the ability to pause the countdown at any time if it detects any data requiring further analysis. And at T-minus 10 seconds, our launch director begins the final countdown, guiding us to the moment we've all been waiting for, T0 and liftoff.
Now, we're just moments away from the start of the auto sequence where Electron systems take over. Let's tune into mission control now as the operators deliver their final callouts before launch. Go iQPS and go Electron.
And from now, there should be no red flags on your critical LCCs. Beacon LD in mission court.
LD Beacon.
Beacon, lock the auto sequence and confirm.
Locked.
Confirm all flight computer ASCOs are green.
All ESCOs are green.
Copy. We are go for auto sequence start at T-2 minutes. LD is go for launch.
The vehicle is fully on internal power. AFTS is green and enabled for flight.
Box load is complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and 2 tanks are pressed.
High flow engine purge enabled.
T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Going to proceed with immediate abort checks. GC, LD, and mission court.
LD GC.
GC, confirm the range state is inhibit.
Confirmed inhibit.
And confirm the stage 1 and stage 2 umbilical status are engaged.
Confirmed engaged.
And confirm no fires on the vehicle.
No fires.
Thank you. Beacon, LD, and mission court.
LD Beacon.
Beacon, confirm the abort auto sequence executed nominally.
This is Mission Control Auckland. As you can see, the vehicle has had an abort during the launch auto sequence. At this stage of flight, the vehicle flight computer is actively monitoring a wide range of vehicle performance parameters, and when any of these parameters are violated, the vehicle has determined it is not ready for flight and holds the count. An abort can be performed at any point up to the release of the vehicle hold down clamps, which normally releases a few seconds after initial engine ignition. Right now, the team in Mission Control is reviewing the data, so we'll stand by while we learn if we'll be able to make another launch attempt today with the remaining in-time window. As you've been watching and listening along, the vehicle's strong back has been resecured and the vehicle has been brought back onto external power. The vehicle has been placed in a safe state while the team reviews the reason for the auto sequence abort. Information on the next launch opportunity and webcast details will be shared on our website and social media feeds. Thanks for tuning in to today's launch attempt, and we are looking forward to seeing you again soon.